We spent a lot of time recently on the building blocks of the cloud. Storage, infrastructure, networking.
All the foundational pieces.
Exactly. How to spin up a server, where to put your data. But there's one topic that ties it all together, and honestly, it's the most important thing, hands down.
It has to be security.
Security.
It absolutely is. In the cloud, security isn't some feature you just, turn on later. It's the framework you build everything inside of.
So if you get that framework wrong...
Then everything, all that infrastructure, all your data is vulnerable from the start.
Okay, so let's unpack this. We've synthesized a ton of reading on how AWS approaches security to really give you a roadmap.
Right.
Our mission today is to give you a clear operational map of the core concepts, what your job is, and the exact tools you need.
The digital locks and alarms.
Yes, the locks and alarms to secure your data, your networks, your applications.
And this deep dive will make sure you walk away knowing the why. Not just the names of services, but why you'd use one over the other.
All right, let's jump right in. There's one single concept that governs all of this, and without it, nothing else makes sense. It's called the shared responsibility model.
I think this is the #1 spot where people new to the cloud get tripped up. They assume, it's in the cloud, so AWS handles all the security.
But the name says it all. It's shared.
It's literally shared. AWS splits the security job into two distinct parts.
Right. You've got security of the cloud, which is AWS's job, and then security in the cloud, which is our job, the customer's job.
And not understanding that difference is, it's often the root cause of major security incidents.
So let's define them. Security of the cloud, what is that?
That's everything AWS does. They're protecting the core infrastructure. We're talking about the physical security of the data centers, the hardware, the networking cables, the virtualization software that keeps your stuff separate from mine.
So I don't need to worry about someone breaking into the data center.
No, you never touch those things, so AWS secures them. It's their job.
Okay, so that brings us to security in the cloud. That's on us.
Precisely. That is everything you configure, control, or put into the cloud. We're talking about your data, the encryption settings you pick, patching the operating system on your servers.
And the firewall rules.
And most critically, the firewall rules you write.
I really like the analogy one of our sources used. AWS provides the secure vault, the reinforced guarded building. But you, the customer, you're the one who sets the combination to the lock.
And you're responsible for making sure the vault door is actually closed. That analogy really highlights the risk. If you launch a server and set the password to password 123...
Which people still do.
They do. And that vulnerability is 100% in your area of control. AWS gave you a secure vault, but you left the combination written on the door.
Okay, so with that model clear, let's get into the tools we use to do our part. Our sources group these into 4 pillars. The first, and most critical, is preventing unauthorized access.
And that immediately brings us to IAM, Identity and Access Management. This is the master control service for your entire AWS account.
It's what decides who can do what.
Exactly. Who or what service can access what resource and under what rules.
Now, IAM has a few key parts. It has users, which are people. It has groups, which are just collections of users. But the one we really need to focus on is the role.
Roles are so important for modern security. They give you temporary credentials. They're often used by services that need to access something, but they can also be used by people who need temporary elevated access.
So instead of a permanent key, it's like a key that expires in an hour.
Exactly. And that's why we prefer roles over users with long-lived keys. Temporary access is just inherently safer. It all ties back to the golden rule of security.
The principle of least privilege.
The principle of least privilege. Only grant the absolute minimum permissions needed to do a job and nothing more. Deny by default.
Which sounds simple, but it takes real, constant effort.
It does. And speaking of powerful users, we have to talk about the root user. This is a public service announcement.
The one account to rule them all.
Yes, it has absolute unlimited power. The biggest mistake people make is using it for daily tasks. You just don't.
So what's the right way to handle it?
You use it one time to create your first admin IAM user. Then you immediately put multi-factor authentication, MFA, on that root user, and you lock the credentials and the MFA device away somewhere safe.
It's the break glass in case of emergency user. That's it.
That's it.
Okay, so we've locked down who can get in. Now let's talk about the walls and the moat. Protecting our networks. That's pillar number 2.
Right. This is where we start defining traffic rules. And we have two main types of virtual firewalls here. First, we have security groups.
Okay, and they attach directly to, say, an EC2 server instance, right?
Exactly. It's a firewall for the instance itself. Then, higher up the chain, you have network ACLs or NACLs. They act as a firewall for the entire subnet.
So what's the real operational difference? They both sound like they block traffic.
The crucial technical difference is state. Security groups are stateful.
Meaning?
Meaning, if you allow traffic to go out, the security group automatically remembers that connection and allows the return traffic back in. It's smart. NACLs are stateless. They don't remember anything. If you allow traffic out of the subnet, you must also create another rule to explicitly allow the response traffic back in.
It sounds like something that could cause a lot of headaches if you forget.
It causes a lot of frustrating outages. So the analogy holds. The NACL is the guard at the community gate checking IDs both in and out. The security group is the lock on your front door.
Okay, got it. But that's just for general network traffic. What about attacks aimed at my actual website or application?
Right, for that you need specialized tools.
So if I'm worried about something like a SQL injection attack where someone tries to steal data from my database through a web form, what do I use?
For that, you deploy the AWS WEF, the Web Application Firewall. WEF looks at the actual web request content and can filter out those malicious patterns that try to exploit your code.
So it's a code-level defense.
A very precise code-level defense, yes.
And what about those huge brute force attacks? A distributed denial of service or DDoS attack that just tries to knock you offline with a flood of traffic.
That is where AWS Shield comes in. Shield is your defense against those massive floods. Shield Standard is actually on by default for everyone, for free. But for high-profile applications, you'd want Shield Advanced for enterprise-level protection.
All right, so we've got access and networks covered. Let's move to pillar 3, data protection. Because even with the best walls, if someone gets in, we need the data itself to be useless to them.
This is all about encryption. You have to protect data in two states. Encryption in transit while it's moving over the network.
And encryption at rest, when it's sitting on a disk somewhere.
Right, in a database or an S3 bucket.
Now, most people get the concept of encryption, but managing the keys, the digital keys you need to lock and unlock all that data, that seems like the hard part.
It is, and that's the job of AWS KMS, the Key Management Service. KMS is so critical because it centralizes the creation and control of those cryptographic keys. And the way it works at scale is fascinating. It uses a concept called envelope encryption.
Envelope encryption, what does that mean in practice?
So instead of using your super secure master key from KMS to encrypt, say, a huge file, which would be slow,
Right.
the master key is only used to encrypt a much smaller single-use key, a data key. That data key then encrypts the actual data.
So the master key just protects the working key.
Exactly. It's much more efficient, and the critical master key itself never leaves the highly secure KMS environment.
That makes a lot of sense. Okay, on to our final pillar, detection and response. We have to assume that eventually a defense might fail. You can't stop a threat if you don't see it coming.
This whole pillar is about knowing what's happening in your environment. And we need to split this into two ideas. Auditing, which is looking back, and detection, which is looking now.
Okay, let's start with the audit trail, the looking back.
For auditing, you have AWS CloudTrail. Think of CloudTrail as the unchangeable security camera system for your account. It logs every single API call made, everything that happens.
So if someone deletes a database, CloudTrail will tell me who did it, from where, and exactly when.
Exactly who, what, and when. It's the ultimate forensic tool. It tells you what happened.
So how is that different from detection?
For real-time intelligent threat detection, you bring in Amazon Guard Duty. Guard Duty uses machine learning to analyze all those logs from CloudTrail and other sources to find suspicious patterns.
So it's not just lagging facts, it's looking for intent.
That's a great way to put it. It's looking for behavior. For instance, if a user who always logs in from New York suddenly starts making API calls from a known malicious IP address in another country,
Guard Duty flags that.
Guard Duty flags that as a potential credential compromise and sends you an alert. It's looking for things that don't fit the normal pattern of behavior.
So CloudTrail is the evidence locker, and Guard Duty is the alarm system going off.
You've nailed it.
Now, security is a continuous process, not a one-time setup.
Yeah.
So what are the resources for ongoing management? Sometimes you just need a checklist, right?
For that, your best friend is AWS Trusted Advisor. It scans your environment constantly and gives you a simple report. Green, yellow, red. It flags common security gaps, like a firewall port left open, or an important user that's missing MFA.
It's your quick fix dashboard.
Totally.
And what if I'm in an industry like finance or healthcare, and an auditor asks me to prove the cloud I'm using is compliant with, say, ITAA or PCI?
For that, you need AWS Artifact. Artifact is just a portal where you can download all of AWS's official security and compliance reports, their ISO certifications, SOC reports, all of it. You give those to your auditor.
That covers a ton of ground. Let's try to synthesize this. What are the core actionable things our listeners should go do right now?
Okay, 4 things. First, access control. Lock your doors with IAM. Use roles, not long-term keys, and live by the principle of least privilege.
Second,
Network defense.
Yeah.
Watch your traffic. Understand the difference between security groups and NACLs, and use WF and Shield for application threats.
number 3.
Data protection. Encrypt everything, in transit and at rest. Use KMS to manage your keys. And finally,
And fourth, detection. Turn on CloudTrail everywhere to log everything and activate guard duty to have an intelligent alarm system watching those logs for you.
and all of that rests on that one core idea, the shared responsibility model. AWS secures the building.
And you are responsible for securing everything you put inside it.
That's the core of it.
It is. And before we go, let's leave you with one final thought. We talked about CloudTrail logging every single API call, mostly for security audits, right?
But who did what when recurred?
Right. So if you were to analyze all of those logs, what's a major operational benefit you could get that goes beyond just security? Think about what all those API calls tell you about how your resources are actually being used. Could you use that data to optimize your infrastructure, or maybe even track costs more accurately? Something to think about.